Dear colleagues, this is a joint presentation by my colleague Associated Professor Nikolay Valchev and me. And the topic of our presentation is experimental seagrass restoration within coastal area, an opportunity for nature-based solutions for coastal protection. Outline of our presentation. First of all, we would like to draw your attention to the grey infrastructure for coastal protection in Bulgaria. Then we are going briefly to tell you a few words about the Forest Bay as an experimental site, and we are going to introduce you to the Rest Coast project and specifically the intervention that we are going to make at the Forest Bay site. We are going to focus on experimental restoration of submerged aquatic vegetation in the bay and modeling the effect of seagrass ecosystem service for coastal protection. The grey infrastructure for coastal protection in Bulgaria. Bulgaria has a long history for coastal zone protection with rigid infrastructure. These structures can be seen all along the coast of our country. And in the past, engineers were focused mainly on smaller rigid structures with the main aim to protect the coastline, and only a few bigger ports were constructed or widened. During the last 15 to 20 years, the coastal engineers' focus has changed, and now we are witnessing a process of coastal rigid structures for servicing boating and yachting. That is, the main focus now has changed, and a lot of marinas has been built and obviously are going to be built in the near future. Currently, there are 29 ports and marinas along the Bulgarian coast, according to the Maritime Spatial Plan for Bulgaria, and in the same document, it is said that there are good premises for significant development of yachting tourism in future, these statements can show us that there is an emerging risk of excessive coastal rigid infrastructure development in the near future, which may come into a conflict with coastal ecosystem protection. Why is that? Because the most attractive stretches for coastal engineers are actually the same which offer the best conditions for seagrass meadows persistence. These are the stretches of the coastline which are predominantly moderately wave exposed to sheltered, and the coastal engineers can benefit from the coastline exposure, and they are attracted into these stretches to build the marinas. But these are actually the locations along Bulgarian coast where the seagrasses can persist, can survive, due to the fact that in Bulgaria we do not have species which soft bottom species which can survive in highly energetic environment. On the contrary, the soft bottom species are wave sensitive. That's why we believe that probably maybe in the future there might be a conflict between the coastal development and the protection of those important habitats. The Forest Bay as an experimental site. The Forest Bay shown on the map with the red circle is a unique place. This is the most wave-sheltered place along the whole coastline of Bulgaria, and it is a focal point of both unique biodiversity and human uses. And there are overlapping economic, social, and cultural interests into this area. There is a potential risk for the biodiversity of the area due to the fact that it is located in the proximity of one of the biggest cities in Bulgaria, and this is the city of Burgas. The city of Burgas is a point where there is concentration of population and different economic activities. The biggest Bulgarian port is also in close proximity to the site. This is the port of Burgas. There are important road and railway road connections here, and a lot of economic activities. And all these may pose a risk on this area, which is also an area with, as I said, very high biodiversity. There is also increasing erosion and flood risk of this area and a risk of water quality deterioration. This is due to the fact that the area is, as I said, is wave sheltered, which supposes that the exchange of water masses with the open sea is to some extent limited. And at the same time, we can see on the map that a large dryland area is drainaged into this point. So this area, this spot, is exposed to high risk of water quality deterioration, eutrophication, and pollution. Previous studies in this area has shown that wave action alone cannot explain the current submerged aquatic vegetation distribution. There are seagrass meadows in this area, and but there is also an unvegetated soft bottom, and the unvegetated area cannot be unvegetated due to the action of waves, because it is a sheltered area. So the main hypothesis which we are assuming here is that probably eutrophication is the factor that prevents the widening of the seagrass meadow. So due to all these unique features of the area, this area is a real challenge for finding scientifically based solutions for its sustainable management. When we talk about the forest bay, we have to say that it is a part of a larger hydrological system, which consists of the watershed of the area, the Mandra Reservoir, the Mandra Lake, and Burgas Lake. And then, as a next step, the forest bay comes. So human intervention, both in a negative or positive aspect, can be done at each of these steps of the hydrological system. As you can see, our focus presently is in the forest bay under the Rest Coast project. We are going to try to make some experimental restoration in the unvegetated soft bottom area, taking healthy plants from a donor population. This is one of the working tasks of the Rest Coast project, which we plan to do in the next few years. A little more about the project. We are going to make some cost analysis of alternative restoration protocols and practices. We are going to make assessment of the success of the transplantation process, protocol refinement, and to recommend management practices. There will be modeling and assessment of selected ecosystem services, and namely coastal protection, carbon sequestration, and biodiversity gain. And proposal for restoration guidelines elaborated in close communication with local managers and other stakeholders. We expect to better understand the technical barriers and enablers working at this area. We expect to prepare restoration protocols and cost analysis we also expect and hope to restore some habitats. We are going to make scenario development with active stakeholder involvement, and we also expect increased ecosystem services benefits. And thank you. And now I will give the floor to my colleague, Nikolay Valchev.
I will not fit in 5 minutes, but anyway, I'll try. So this is the second part of the presentation. Thank you, Elitsa. And it's about modeling, because the use of a numerical model can greatly help and enhance the activity of so-called hands-on restoration. So our modeling activities will be concentrated to define what is the hydromorphological condition that impact the current status of the ecosystem. So we have this result, obviously. As Elitsa said, the part of the should be vegetated area is not vegetated, so this must be either or wave or currents, but it is not very likely, or eutrophication. So the result will be the risk assessment from these multiple sources, originating from meteo conditions, but also from oceanographic impacts, but also from other sources that will be measured, mostly physical-chemical characteristics, and also there will be another measurements of wave height, currents intensity, and discharges from both lakes having impact on the area of Forest Bay. And you can see here a model chain. I will not explain in details, but we are going to use a flexible mesh Delft3D wave flow model that will allow the best way to incorporate not only the hydrodynamics in the bay, Burgas Bay and Forest Bay itself, but also the interaction with the two lakes. And then when we have this wider picture, we have also include a framework of possible scenarios that are related with climate change. We spoke a lot about climate change today, but you know, one phenomenon of a storm cannot be considered climate change itself. Here we have different kind of scenarios, and these are both scenarios that are related to concentration of green gases. It is under RCP, so representative concentration pathways, but also SSP, which are shared socioeconomic pathways. So there are like one to another, they are related. So we have two scenarios that will be used in order to somehow quantify the climate change related to sea level rise, currents, speed, wave height, etc. And also on the other side, we have exposure vulnerability assessment of coastal receptors. And these are infrastructures, population, habitats in terms of ecosystem. And all this together with different scenarios of ecosystem services, for example, zero scenario or positive scenario that we have restored quite a lot of what we expected from the seagrass meadow, but also scenarios that forecast or predict loss of seagrass because of worsening of conditions. They will be put in a matrix that also can be assessed through numerical model, but also through statistical models and statistical assessments. And these are our goals in this field. And coming to the core of presentation is the natural-based solution. We look on them like a building blocks that will allow us to analyze the hands-on restoration, what what is their result, and to have a wider picture if other building blocks, other nature-based solutions, we are that are quite plenty. I will show you later, can be somehow implemented together in order to have a synergy of their effects and to get what we want as a coastal protection, because now we talk about coastal protection, but also Elitsa has mentioned that we would like to see how a restored meadow field would increase the biodiversity or carbon sequestration. What we expect is to help elaborating local restoration plan and improve knowledge of and better adaptation strategy. And the picture is very important. It's not for the site, but we today together we speak about wetland and also coastal ecosystems, and both they are very connected and very dependent, and they are like a buffer, like for in order to protect the shore. For example, speaking about coastal protection, wetlands can be a floodplain. And then they could prevent larger economic losses in case of large flooding, and of course if they are I don't know, urbanized, or they do not implement their function, it would be of course catastrophic. I don't know, maybe it's too strong word. And on the other hand, the restored ecosystem, as we can see, we'll see later, they can prevent coming larger waves than expected, or they can lessen the current speed.
Excuse me, Nikolay, sorry to interrupt you, but you promised not to speak more than 5 minutes, and I'm scared that you said
a short,
as we will see later. So please,
just a short clip. It is from one of our partners in the project. It's called EcoShape. It's in fact an association of NGOs that are building with nature. So using what nature is giving to us, and we are somehow enhancing with a smart engineering decision in order to achieve better results. So you can see here quite a lot of nature-based solutions like building blocks, and I will show you what is for restoring seagrass. You can see here seagrass restoring seagrass as a building block, and here is an overview, and this information is freely available. You can see here, for example, what are benefits and what are somehow disadvantages. I will not go in details. And of course, some decision tree here in order to choose the best solution for certain implementation of nature-based solution. Yeah. Okay. Thank you very much.